Okay, so last time we started to talk about what an experiment is, what an event is, or what a sample space is, right? So let's quickly review that. So what is an experiment? An experiment is a process by which an observation is made. We are going to make two assumptions here. The outcome of the experiment is not known in advance. However, the set of all possible outcomes is known. So an example would be toss a coin and observe which side lands facing up. And in this experiment, we see that until you actually flip a coin, you can't tell in advance whether you're going to get a head or a tail. However, you know all possible outcomes. So in this case, we're going to use S to denote the set of all possible outcomes of the experiment. And in this case, it is either a head or a tail. Okay. Sometimes we also use omega. Sometimes we also use omega to denote the set of all possible outcomes. And if you toss a die and observe the number of dots, right? In that case, the set of all possible outcomes will be given by the numbers 1, 2, 3, 4, 5, and 6. So when you have an experiment, the set of all possible outcomes of the experiment is called the sample space. Okay. Once again, a sample space will be denoted either by uppercase omega or by uppercase S. If the outcome of an experiment consists in the determination of the sex of a newborn child, then what's the sample space? Well, we could say that the sample space would be F or M, female or male. If the outcome of an experiment is the order of finish, in a race among 7 horses, having post positions 1 up to 7, then what is the sample space? Think again. The outcome of the experiment is the order of, so you're observing the order of finish of the 7 horses. So how what is an outcome here? How does an outcome look like here? It's the order of finish of the horses, right? So what is that? What's the order of finish of the horses? Is that a permutation of the 7 horses? So the sample space here would be all possible ordering of the 7 horses at the finish line, right? So that means this is the sample space would be permutations of 7 horses. Okay, can someone tell me the order of the sample space? By the order, so I'm going to use this symbol by I'm going to write S within the absolute value signs to denote the order of the sample space, which means the number of elements of the sample space. So how many elements do I have in the sample space? How many elements do I have in the sample space? Seven what? Just 7? The sample space consists of all permutations of 7 objects, right? How many permutations are there of 7 objects? 7 factorial, right? There are 7 factorial permutations of 7 objects, right? Is that right? Okay. Okay. If the experiment consists of flipping 2 coins, then what's the sample space? Well, let's say here on the first column I'm writing the results of the first coin and the results of the second coin. I'm writing on the top row here. So then what are the possible outcomes from flipping 2 coins? Well, I could get HH or HT. I could get TH or TT. So in this case, the sample space would be HH, HT, TH, TT. Okay. Any questions on that? Let's flip 3 coins. If you flip 3 coins, then what is the sample space? If you flip 3 coins, in order to come up with the sample space, one thing you could do is, first of all, write down the possible results from the first coin. So from the first coin, you can get either a head or a tail. Now, if you get a head from the first coin, right, then you can get either a head or a tail from the second toss. Or if you get a tail from the first, then you can get either a head or a tail again. So these are the possibilities after the second toss. And again, you keep doing that. So if you get a head followed by another head, then you can again get either a head or a tail. If you get a head and a tail, then you can get a head or a tail. Let me make a little bit more room here. Okay, so if I get a head, then I can again get a head or a tail. If I get a tail, I can get a head or a tail, right? And so this is like a tree diagram of all possible results that I can get. So in order to read off the possible results or the outcomes, we see that I can get H, H, and H. So that's one possibility. I can get HHT, HHT, right? What else can I get? I can get HT, H, right? I can get HTT, or I could get THH, THT, TTH, TTT, right? Is everybody okay with that? So those are the possible outcomes from the 3 coins. Now, how many outcomes do we have here? Well, notice that the order of S is 8, which is the same as 2 cubed, right? And we can just count it by using the counting principle. So you have results from 3 coins. So from the first coin, you can get 2 possible outcomes. From the second coin, you can get 2 possible outcomes. From the third, you can also get 2 possible outcomes. So the total number of outcomes would be 2 times 2 times 2, which is 8. Okay, let's say you toss 2 die. If you toss 2 dice, then what are the possible outcomes? Well, let's say you from the first die. So the first column gives you the outcomes of the first die. The first row gives you the outcomes of the second die. So what are the possible outcomes from the 2 dice? Well, I can get 1 1, I can get 1 2, 1 3, 1 4, 1 5, 1 6, right? I can get 2 1, 2 2, 2 3, 2 4, dot dot dot, and so on, right? So go ahead and fill out the table. So what's the total number of outcomes if we toss 2 dice? 36. So the sample space is, so in this case the sample space has order 36, which is not a surprise. It is 6 squared. So why do we get 6 squared? Because we have two dice. So this is how many outcomes can I get from the first die, and how many can I get from the second one? Well, there are 6 possible results from tossing the first die, and 6 possible results from tossing the second. So there is a total of 36. outcomes if we toss 2 dice. Is everybody done completing the table? I'm going to refer to this table many times in the future whenever I use this experiment of tossing 2 dice. Is everybody done completing the okay. Let's say you observe the lifetime in hours of a transistor. So if you observe the lifetime in hours of a transistor, then the sample space will be the set of all real numbers x such that x is non-negative. That is, the sample space here is the collection of all non-negative real numbers. Let me emphasize that here. So x is a real number. Okay.